Hi, solving science, gravity. By the end of this video, I'm going to tell you why I believe you are standing or sitting or lying on the ground, which I don't think anyone has ever known before. So hold fire, and as I review the history of gravity, I'll go through all the major players and what they did, and then what they didn't do and what they didn't achieve. And by the end of it, I'm going to tell you why I think you are standing on the ground today. So look, gravity, it affects every single one. For hundreds of years, we've been studying what is gravity. Now, it begins with Aristotle, the first thinker to really think deeply about what gravity was. And he simply believed that physical objects attracted each other. So he just thought that physical things like Earth and wanted to join together. So objects wanted to be near the surface of the Earth. It was his thinking. Then Galileo came along and he showed that all objects of different mass fall at the same rate. And it fundamentally changed the thinking that had gone on from Aristotle. Now, the major breakthrough was Robert Hooke, who was a prolific experimenter, and he ran his whole life running experiments. He gave a presentation to the Royal Society in London that said for the first time gravity was proportional to the distance between objects. Now, he didn't have the mathematical ability of Newton, who came along and put the mathematical formulation behind that. But actually, it was Robert Hooke that started to pin down the proportionality of the distance between masses that related to gravity. He was the real genius. Only a few years later, standing on the shoulders of giants, as Newton admitted, he obviously published his thesis and work and the formula that we do, which said that the square of the distance between masses produced a calculation that explained gravitational attraction. Action at a distance without a medium between them was Newton's thinking. He said famously, he didn't feign hypothesis. He didn't know why gravity worked. It just worked, and he didn't want to look any further. So gravity was a mathematical calculation based on calculus, but not physical cause. That survived for a few hundred years until the incredible Albert Einstein came along and said, hang on a minute. He replaced calculus with geometry. Curve without substance. Still no medium, no substrate, no causal why. What Einstein did was give us the mathematics to explain more deeper gravitational aspects. Particularly look up the orbit of Mercury, which Newton's equations couldn't resolve. So Newton gave us something called the curvature of space-time, but it's without substance, it's without physical cause. And he chased that to his dying day, knowing full well that his mathematics to explain the how of gravity didn't explain the why. Now, for the last 60 years, since the death of Einstein, we've had two camps. We've got the quantum gravity camp, who are busy looking for the graviton, quantized graviton of gravity. No, I'll explain why in a minute. And we also then have a whole load of patches, dark patches, to explain dark matter and dark energy. Now, this is just cheating. It's cheating. Okay, so dark matter, dark energy comes along because we can't explain flat rotation speeds of galaxies. The outer region of galaxies and low density are spinning too fast for the gravity as caused by the curvature of space-time maths explained by Einstein They can't explain the speed that the outer regions of galaxies are rotating. We have lots of other problems as well, but dark matter, a patch, a fake, a cheat, little mathematical cheat. Now, why do I think you're standing on the ground today? So, expanse tension theory inserts a scalar field, a quantum field into the universe. Fully quantum field theory permitted. It's actually called a real gauge invariant singlet scalar field that couples with Higgs portal with a continuous density dependent modulation. It's a complicated way of saying in various density situations, environments, the extreme low density of galaxies or the extreme low densities where we have late time acceleration, by the way, that's dark matter, dark energy, but also the extreme high density of neutron stars and pulsars and the event horizon of black holes. The physics change with environment dependent density. Now that field, I believe, is around us, around you, around the Earth, and it's trying to expand. Since the energy released into that real field, real substance, real medium that Einstein was looking for, that real field is pinned down by mass, resisted by mass. And here on the surface of the Earth, with acceleration of the universe happening above us, 70 kilometers per second per megaparsec, somewhere above our heads, but we're not expanding at 70 kilometers per second per megaparsec. Now, that alone can't justify it, but if you insert the field, that field is under tension because mass is resisting that field, and that field is pinned down by mass. Now, wherever you have a net flow imbalance in a field, in the flow of a field, it necessarily triggers an inevitable reaction force. That's the engineer in me. You have a tension gradient between expansion above us, resistance to expansion. That inserts a tension gradient. That tension gradient causes emergent gravity that we experience. The acceleration we experience is simply us traveling the steepest gradient in that tension field of this hypothesized field, fully permitted. Expanse tension theory hasn't inserted any exotic physics or phantoms or crazy ideas. It's fully permitted within normal existing quantum field theory. So expanse tension theory says that gravity is the reaction to the net flow imbalance that's inserted into this field because mass resists the tension field. It interrupts this field and it creates a tension gradient. Now, so far I've applied that logic not only to Earth, Moon, Saturn, Venus, Sun, calculating the acceleration due to that net flow imbalance, and that gives us the figures that we would see with Newton and Einstein. So predictive is very high. I can also use the density dependence of expanse tension theory gravity, tension gravity, to explain why at a falling density in a galaxy's outer regions do we have the transition to what's called dark matter anomalous flat rotations. By the way, there is no dark matter. There is no dark energy. Again, coupling, modulation of a scalar field can give us all of the effects we need. That's fun, isn't it? So, come back to gravity. What is gravity? Well, it's not as Newton described mathematically. It's not action at a distance without a medium. We have a medium. It's not the spookiness of curvature of space-time, although Einstein was most correct mathematically, but it lacked substance, and he acknowledged that. He told us to continue the search. There is no graviton. Gravity isn't quantized. We will not ever reach quantum gravity because of that status. However, what we will do is have a quantum field theory of gravity. Using quantum field theory, we can explain gravity using that basis. Now, that means we've integrated and incorporated gravity into quantum field theory, which is the ultimate objective. The conflict between classical gravity, Einstein, and quantum field theory. That has been achieved with expanse tension theory. I think you are standing, sitting, or lying on the Earth because you exist in a tension gradient of a scalar field that's under tension as the mass of the Earth resists the expansion of the universe and the tension that puts into this field. That mass is pinning this field down and causing a net flow imbalance reaction. And that's physical cause. That's actually all I set out to do. For the last 40 years, I set out to find the causal mechanism of gravity. And I believe that's it. Because that one simple, elegant piece of physics, one simple quantum field theory permitted idea, so far has resolved 1,000 other anomalies across the universe, which I did not set out to do. But anyway, please give me your feedback. Now, this is a very intuitive idea of gravity, because by intuitive, it's logical. It's an engineer's explanation of gravity. It says a simple reaction to flow. Well, that's engineer's physics, okay? The net reaction to tension will provide a force, okay? So I think that's why it's exciting. Thank you for listening. Okay, bye-bye.